All right. I understand. Just get it going. It's fine. This was here. Did you guys see that?
Yeah.
It's there. All right. These notes are pretty quick, in my opinion, I think. So here we go. And algebraic expressions. That's what we've been working on, right? We introduced expressions last time. Like terms. Remember we talked about terms last time. Now we're talking about like terms. Like terms are terms that have the same variables raised to the same exponents. Okay? I think this line's also underlined too. Constant terms are also like terms. So constants are also like terms. Okay? So here are some like terms, right? 3 and -4. Those are both constants. -2x and 7x. Those are they both have the same variable raised to the same exponent. What's the exponent on that x? What's the exponent on that x? The exponent on the x. You don't see it, do you?
No.
So how many x's are there?
None.
There's one. X to the first. But there's only one, so it'd be x to the first. What's this exponent? 1. It's invisible. Every number has an exponent of 1 raised to it. Just like every number you can put over 1, right? Or every number you can multiply by 1. Right? Same value. So what we want to do is we want to first identify the terms and then identify the like terms for each expression. Okay, so the first thing we're going to do is identify the terms. Now we used the circle method last time, right? I might have mentioned in class that we're going to refine that method a little bit. We're going to go from the circle method and morph it. It's like Mighty Morphin Power Ranger style. We're going to metamorphosize. Is that a word? Metamorphosize?
Yeah, it is.
Yeah. We're going to change it from the circle method to the shape method. Okay. So, sorry, I forgot about unlike terms. Unlike terms are those. So what we want to do is we want to have the unlike terms have different shapes. So if I was going to pick a circle for x, then I would pick a square for 5. Or if I was going to pick a triangle for x, for terms that have an x, I'd pick a squiggly circle for terms that have a y, right? There's different shapes, okay? So when we look at this one, let's identify the terms. We're going to use our shape method. What I want us to do is I want us to just pick a circle, right? And we'll circle the first term. Notice how that term has an x. I want you to go through the entire thing and circle any other term that has an x, okay? The other term that has an x is the last term, -x. Now we should have all the terms that have an x circled. And now I'm going to pick a different shape, a square. And I'm going to circle all the terms that don't have an x, because those are constants, right? And by circling, I just mean I'm going to make a rectangle. All right? This is the shape method. It's like the circle method, but it's with shapes. Okay? So now we have identified how many terms are there? There's how many? There's 4 terms. So let's list those terms. 9x, -2, +7, and -x. And now let's identify which ones are like terms.
9x and x.
Exactly. 9x and x are like terms. 9x. And it's not x. And -x. And the other like terms are -2 and 7. Coolio?
Yes, sir.
These have the same variable raised to the same exponent, and these are constants. Notice the definition up at the top. Okay. Okay, let's do the next one too. So let's just pick a shape for the first one.
Triangle.
I'm going to use circles. I use circles every time for the first shape. So now I need to find any other terms that have a z squared in it. And that's not 5z. Notice this is z squared. Does this have a z squared in it?
No.
Does this have a z squared in it? Yep, so I'm going to circle that guy. Does the last one have a z squared in it?
Nope.
Nope, so now I pick a new shape. And I just go to the next term that hasn't been circled yet.
Yep.
The next term, I'm going to use a rectangle. See how it's almost like the circle method, just a little bit different?
Yes, sir.
It's like the circle method on steroids, right? We're like, yeah, circle method, shape method. All right, and now we go through. Let's list the terms. Terms are z squared, 5z, negative 3z squared, and z. The like terms
Are all of them?
well, they're not all like terms. Why? Well, because like terms have the same variables raised, read with me, raised to what?
Oh, so the same.
Raised to the same exponents, okay? Raised to the same exponents. So, like terms would be the ones that I circled, and then the ones that I rectangled. So the circled ones would be z squared and negative 3z squared. And the other one is 5z and z. That's the difference between like terms and just terms, okay? I want you and your partner to try those. Here we go. Identify the terms and the like terms, okay? Identify the terms and the like terms for those. Use the circle, use the shape method, please. First one's up there.
This one is yeah.
Careful on number 2, right? Identify the terms first, then the like terms second. Next one. The like terms are 7. All right, and that's the last one. How we do? So, were you careful on number 2? Notice how 7r and negative 9 have different shapes and different colors? Different shapes and different colors? Same thing on number 3, right? There's 2 sets of like terms on number 3, right? Both the red and the green?
Yes, sir.
Cool. So the whole reason why we need to practice identifying like terms is so that we can combine them, right? Like we did on the quick quad today. All right? So we want to simplify algebraic expressions. That's the whole purpose of what we're doing. So we want to simplify them. An algebraic expression is in simplest form when it has no like terms and no parentheses. Today we're going to focus on the no like terms. Next time we'll focus a little bit on the parentheses. Okay? So no like terms and no parentheses. So what we want to do is we want to use the shape method, right? And then we want to wrap those like terms. Like terms.
Like terms.
Exactly. For real though, like we want to use the add wrap. That's what we're going to do. All right, so let's simplify this one. First off, we want to identify those like terms. We use the shape method. So I circle my 6n. Do I have any other n terms? I do. Look at that, negative 10n. Hey, all right. I've got some like terms. Let's add wrap those, right? So what am I going to do? I'm going to go same sign, add, different sign, subtract, and keep the sign of the bigger one so we can be exact. Exactly. So I got 6n plus negative 10n, right?
Yes.
That's a subtraction problem. What's that going to be? Done. Now, do you have to write this step? No. But if you wanted to think about this as keep, change, change, you can. I wouldn't. I would just use the wrap. Right? Same sign, add. Different sign, subtract. So 10 minus 6. Keep the sign of the bigger one so I can be exact. Right? Cool? So let's do this one now. Same process. Use the circle method first, or the shape method. We have to use the shape method on this one. So do I have any other y terms? Terms that have a y in it? Yes. Now, what if there was a y attached to the z? What if it's at 4zy? Would that be a like term with this one? No, because they would have a different set of variables. They have to have the exact same variables raised to the same exponent. All right, and then looks like we're going to need a different shape. I'm going to use rectangles. Let's combine only our like terms, right? We can only combine like terms. Unlike terms do not simplify. So I got, ready? Same sign, add. That's all we need, right? Look at that. Same sign, add. Keep the sign of the bigger one so we can be exact. Good. So I got negative 8y. And then, once again, same sign, add. Keep the sign of the bigger one so I can be exact. So same sign, add, which gives me plus 13z. That is my final answer. Notice how the direction said simplify. Simplify means combine like terms. Okay? Simplify means combine like terms. Write that in on your notes. Write that in somewhere. Simplify means combine like terms. Simplify means combine like terms. Okay? Which means we're going to, on 4, 5, and 6, what are we going to do? We're going to combine our like terms. All right, you and your partner. Get going. Please practice the circle method, or the shape method, excuse me, even on the first two that are pretty straightforward. Don't forget on number 5, your rules for adding fractions. Hey, check your first two. Y on number 5. Hey, y'all. Y on number 5. Am I subtracting? Ashley? Exactly. So since they're different signs, we have to subtract. And which one is a bigger fraction, 3/8 or 3/4? Well, 3/4 is a greater fraction because 3/4 is bigger than a half. 3/8 is smaller than a half. Right? So 3/8 is the smaller one. We always subtract big minus little. And we get negative 3/8. Why? Because 3/4 is greater than 3/8. Don't forget to do 6 as well. This is the last one. How we do? How we do on that last one? How we do on the last one? 22 minus 2z. Hey, guys, just so you guys are aware, you can also write it like this. Negative 2z plus 22. You can write it either way. Either of those is appropriate. Typically with expressions, the variable term will come first. So if you see answers where the variable term came first, all they did was they used the, what is that? Is that the associative? No, it's the commutative property of addition, which says I can change the order, right? That's the commutative property of addition.